In this video, we are going to discuss determination of internal resistance of a cell by using potentiometer. This is the circuit diagram for determination of internal resistance of cell. It consists of a long uniform potentiometer wire AB which is connected across the battery of EMF capital E through the plug key capital K, and a rheostat RH is connected in series. The cell of EMF E1, whose internal resistance small r is to be determined, is connected with its positive terminal to end A, where positive terminal of battery E is connected. The negative terminal of cell E1 is connected to the jockey through the galvanometer. A resistance box capital R and the key K1 are connected in parallel with the cell E1. Here E must be greater than E1, that is, potential difference across the wire AB must be greater than EMF of cell E1. In order to determine internal resistance of cell, initially plug key K1 is kept open and key K is closed so that the current I start flowing through the circuit, which creates uniform potential gradient along the potentiometer wire AB. Now, by touching the jockey at different points on the potentiometer wire AB, the balancing point P is obtained, for which galvanometer shows null deflection. That is, potential at point P and potential at the negative terminal of the cell E1 is same. Means we are not drawing any current from the cell E1. So the cell E1 is acting like open circuit cell. In this case, the length of wire between AP is called balancing length for the cell of EMF E1. So let AP is equal to L1, which is nothing but balancing length from higher potential end A of wire AB. As no current flows through the cell E1, the potential difference across wire AP of length L1 is proportional to the EMF E1 of the cell. Therefore, by the principle of potentiometer wire, we can write VAP, that is E1 is directly proportional to L1. Therefore, we can write E1 is equal to I sigma L1, where sigma is resistance per unit length of potentiometer wire. Or we can write E1 is equal to K L1, where K is equal to potential gradient. Let this equation as equation 1. Now, we are going to take out a suitable value of resistance capital R from the resistance box and closing the plug key K1. Now, by closing the key K in the circuit, the current capital I will start flowing through the circuit, which gives uniform potential gradient along the potentiometer wire AB. In this case, by putting the key K1 in the circuit, the current will start flowing through the resistance R, which is supplied by the cell E1. That is, in this case, we are drawing some current from the cell of EMF E1, which will create the potential difference across the resistance R. Now, by touching the jockey at different points on the potentiometer wire AB, the balancing point P' is obtained, for which galvanometer shows null deflection. That is, potential at point P' and potential at the common terminal of the cell and the shunt resistance R is same. In this case, the length of wire between points AP' is called the balancing length of the wire for the potential difference V across the cell. Therefore, let AP' is equal to L2, that is balancing length from higher potential end A of the wire AB. As current flows through the cell of EMF E1, the potential difference across the wire AP' of length L2 is equal to the terminal potential difference of the cell. Hence, we can say that VAP', that is potential difference across the wire AP' is equal to V, which is nothing but terminal potential difference of the cell E1. Therefore, according to the principle of potentiometer, we can write V is directly proportional to L2. Therefore, V is equal to I sigma L2, where sigma is nothing but resistance per unit length of the potentiometer wire. Or we can write V is equal to KL2, where K is nothing but potential gradient. Let this equation as equation 2. Therefore, from equation 1 and 2, we can write E1 by V is equal to L1 by L2. Let this equation as equation number 3. Now, by applying Ohm's law to the loop A, B, C, D, A, we can write E1 is equal to I into capital R plus small r. Let this equation as equation number 4. And the potential difference across the resistance R is given by V is equal to IR. Let this equation as equation number 5. Now, by dividing equation 4 by 5, we can write E1 by V is equal to R plus small r upon R. Let this equation as equation number 6. Now, by comparing equation 3 and 6, we can write L1 upon L2 is equal to R plus small r upon R. Now, by rearranging the term, we get the final equation as the internal resistance of cell small r is equal to capital R into bracket L1 minus L2 upon L2.